Good evening, everyone. Welcome to video number 4 of the IA discussion series. And until yesterday, we have seen 3 different problems, 2 on mechanics and 1 was on thermal. And today, we will be looking into one more, which is related to buoyancy or the sinking effect. Okay, let me share my screen. Let's begin with this. Right. So this is problem number 4. And here the idea was something like this. You take a bowl, for example, and keep it in a, what do you call it, tray of water, or maybe a tank of water. And you see that, okay, if there's a hole, then automatically the bowl starts sinking to the bottom. So now the question is, on what factors does this actually happen? The first is the hole. Okay, now the next question, obviously, which you can say is, maybe even if you have a hole, if the mass of this bowl is much higher, then definitely it will sink faster. Now, what is that we are asking? Speed. How does the variable affect the sinking speed of a bowl with a hole in a fluid? Now, we can say about the sinking speed using a hole, or maybe you can say not one hole, if you have multiple holes, also it's possible, and so on. So, there could be several variables that we can have. Okay, now let us look at what are the different possible variables we have and how do you address it? Which variable is the best one? So, we'll look into all this. So now let us do a brainstorming. So this is the kind of bowl that we have, and this is a small hole over here. Okay, and then the starting idea is that, so let us say you can increase the weight of the bowl. Okay, if it's a plastic bowl, might be it will take a long time to sink. Okay, because there's a buoyancy there. And if it is something like a metallic bowl, it can easily sink it too. Then again, depend. So therefore, this idea is always a welcome idea. This is a welcome idea. Okay, so as I increase the weight of the bowl, then definitely the sinking speed could be faster. And density of the fluid. What about density of the fluid? Of course, it also depends upon density because there's something which is related to flotation. And whenever you talk about a flotation, definitely it depends upon the type of the material and as well as the type of the fluid. So therefore, it depends on this also. Then shape of the bowl. Now, as for example, you have a shape like this. Okay, so it takes a long time. Let us say, for example, I have a shape like this. Then there's a hole over here. What can happen? So water can ooze over here, and after some time, this can become like this, and water can enter from here also. When the water becomes like this, water can enter from here, and as a result of it, it can easily sink into. So therefore, shape of the bowl is also very important. So this also depends on this. Diameter of the hole. See, I put a very small hole over here. If suppose if the diameter of the hole is much larger, okay, so if it is much bigger hole, what will happen? Immediately it will sink down. So therefore, it also depends on this. 4 parameters you got. See, you thought of doing only one IA, but you can vary any one of them. Still, you are now getting it across, right? Then position of the hole. Now, let us say, for example, if the hole is not here, if the hole is fixed over here, do you think this will sink? It will never sink, right? Or maybe I can also ask a question like, okay, I have a flat bowl. Okay, I can put a hole here. If I putting a hole here, it will sink. If I put a hole here and here instead of this, 2 holes, or maybe I put only 1 hole over here, then do you think it will sink faster? Same diameter of the hole, but the only thing is that, instead of having the hole here, I am going to put the hole here at the base. Okay, but at a different point. What will happen? Water will now start oozing inside it like this over here, and water will collect over here. This part of it becomes more weight. Okay, of course, water will start spreading. So as a result of it, this will now start tilting like this, and water will immediately start entering, and the bowl will immediately sink across, right? So therefore, this is also a possibility. Position of the hole we have said. Then bowl type or density. What is the type of the hole? Of course, you can say these two are identical. Okay, bowl type or density and the weight of the hole. These two are same. Okay, so therefore, I have around 6 ideas out of which 2 are identical. Maybe I can measure the weight here. I can measure the density here. Okay, but doesn't matter. What we can do is oh, I'm sorry. Density is different. Density refers to the type of the object. I can use a metal, I can use a wood, for example, I can use a plastic, I can use anything over here. And weight refers to only one metal, but or one type of density, but the masses of this are different. Okay, so totally we have 6 different types of ideas. Next, what we need to do is regular protocol. So how do you narrow down these ideas into focused questions? Which question can we proceed from? That's the question now. So towards it, what we do is we go with an available apparatus. What are all the apparatus we require for doing all this? Let us see whether we get the apparatus. Weight of the bowl, we need a weighing machine. We get this in the lab. Density of the fluid, displacement method. You can take a beaker, you can immerse this one, find out what is the volume of contained into it. You can do this one also. No issue. Shape of the bowl, of course, you can design the shape of the bowl, whatever bowl, whatever. No, that is the problem now. Shape of the bowl, you have to decide what shape you want. Of course, you can get it in Amazon. You can do this also. Diameter of the hole. Okay, you can take a drilling machine and you can increase the hole diameter, decrease the hole diameter. You can do whatever you want, right? So this also no problem. Position of the hole, that also is at your will. Okay, you can put it at the center, you can put it in the corner, you can do whatever you want. Bowl type density. Okay, so this is also at your will. You can change the density. Now, so therefore, based on the type of apparatus, okay, all the apparatus is available. So therefore, this method will not work for us, right? So every time this method may not work. Okay, sometimes this method may not work also. Now, what's the second method to focus this? Okay, to narrow this down. So the second method is nothing but which of them will give us a proper answer. Now, if you see, for example, let us look at one by one. Now, starting idea, weight of the bowl. Now, how do you choose the weight of the bowl? Do you get, so whenever we choose an independent variable, because the focus here is nothing but sinking time. Sinking time is nothing but your dependent variable. This is your dependent variable. But independent variable, what is independent variable? That's what we are looking at. Now, if I choose this as weight, then what do I need? I need the weight to be focused in same intervals. Let us say, for example, you have taken the first bowl to have a weight of 50 grams. The second should have 60 grams. Third one should have 70 grams, 80 grams, and so on. Okay. So if that is the case, then you can do this. Do we get bowls of the same size? Of the same weight or different weight like this at equal intervals? You may not get it. Then what is that you do? Now, one of the students, when I was discussing in the class, so 2 years, 3 years before, okay, he suggested, why not we add weight to it, right? That can be done. So what you can do is, if I have a bowl like this, okay, now what you can do is, so you can add some weight to this. How do I add weight? Whatever I want, I can put some glue over here, I can put some material over here, and as a result of it, weight will increase. Okay, so this is an excellent method. You can still do it. So the thing that he proposed was that he said, sir, we will add something like a few metal nails over here, put a magnet here, few metal nails over here. If I put 3 nails over here, put 3 nails over here, put a magnet over here. The nails weight and the magnet weight will be the same, so it will be balanced. But we were not able to do this one correctly. The reason is because though we do something like this, okay, the nail weight will not be the same. There might be a difference. How much difference was it? It was having to be a difference of around 2 to 3 grams, which means that initially the bowl without any nails or anything that has been added over here was seen to be 50 grams. Okay, when I added all of them, this came to be the first one. When I did this, was seen to be 62 grams. The next one was seen to be 76 grams. The next one can be something like 95 grams. Okay, this was the problem. So I put a magnet over here and I keep on adding nails, because magnet attracts the nails, and as a result of it, it will not escape, and even though it falls down, nothing can happen, it is in balance. But unfortunately, the balance was not seen. So the cup used to, see, I used to take a tub of water like this, okay, and immerse it like this over here. So after a while, what happens is the cup used to topple down like this. So that clearly tells us that my experiment is not going well, right? I want this one, the sinking, to be purely happening only due to this hole. Because if this happens, what happens is sometimes it will go like this, right? Sometimes the orientation can be like this. Sometimes the entire thing can sink like this. For example, if I'm doing 5 trials for every observation, okay, if one trial goes like this, other trial goes like this, other ones go straight, then I don't get a proper answer. Okay, so therefore, this method was not considered to be suitable for me. So I left this across. Okay, so therefore, weight is not an useful measure. Of course, you have to be very careful while you do it, so otherwise you won't get it. Now coming back to this one, I'll come back to the rest of them also. The bowl type or density, the same problem once again. Okay, even you try it in Amazon or India Mart or wherever it is, you may not get the same equal interval of density. Okay, let us say for example, the first one you get it is something like around 800 grams per centimeter, sorry, 1200 grams per centimeter cube, or 12 gram per centimeter cube, 14 gram per centimeter cube. This is what I should get. Okay, but unfortunately, you won't get like this. You may get 12 initially, then you might get something like around 8, then you might get something like around 27. So therefore, equal distance is not maintained. So there's no point in going for density also. So therefore, this also is being ruled out. I will not go with these two. Maybe if you are interested, you can go with this one, but I don't recommend to go with this one. This strictly you may not get this, but this one you might be able to get it. You can put, if you don't get a proper result, you can put it into evaluation. So that's always possible. Density of the fluid. Now, how do you vary the density of the fluid? Once again, don't tell me you're going to add salt to it or sugar to it and thus varying the density. That will not work. Okay, density will not vary in an equal increment. So therefore, don't use that one. Density of the fluid also is the same problem. You will not get densities which are incrementally increasing. Okay, so as a result of it, I won't go for this also. Okay, so there's nothing wrong in taking something like you take water, you take oil, you take castor oil, you can take different types of oils and do it. Okay, but the thing is that why should I use an experiment like this with an oil? That's the main question, right? So whatever experiment we do, okay, we see to it that something relevant is coming out of it. Okay, so what is the relevance that we find here? For example, if I have a canoe, and in the canoe, if there's a small hole into it, and if the small hole is at the center, then what can happen? And if the small hole is at the side, then what can happen? So what is the difference in time, in the sinking time taken? That is what we can investigate using this. Okay, and all this floats only in water and not into anything else. And the sea water's density will not change from one point to another point in a very varied way. So therefore, I would not be going to the idea of density of the fluid. Shape of the bowl. Definitely depends on shape of the bowl. Okay, but the problem here is that we started with a hole like this over here, with a bowl like this, and made a hole like this over here and so on. But what happened when we did this, when we have something like a concave, okay, see, let me take up a new slide. If I take a bowl shape like this and I drill a hole here, there's a possibility that, okay, so this part, okay, might break off, okay, or the hole might be widened this much. Okay, so it was not very much correct properly for me. That's one thing. And secondly, when we talk about the shape of a bowl, what do you mean by shape? Okay, so that is the main thing that we need to look into, apart from this hole over here. Okay, this one tells you what kind of shape do you want to take. But when you say about the shape, what kind of shape variation can you expect to? Okay, are we going to change the radius of this? Is that what you mean by shape, or something else? Now, until and unless that is not clear to us, it becomes very difficult. So usually what we think was that, okay, might be I will take a shape like this, 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 and so on. But when I am doing something like this, then what is that I'm doing here? What is it I'm varying? I'm not clear about it. So there's no point in going for these kinds of things. Okay, let me look at the other idea. So therefore, I will discard this also. Now I am left out with diameter of the hole and the position of the hole. Both are equally weighing. Okay, so I can either choose idea 1, idea 4, or idea 5. Idea 1 is a bit difficult, but of course doable. Idea 4 is always doable. Diameter of the hole. If I increase the diameter of the hole, so how do I increase the diameter of the hole? I need to increase the diameter of the hole like this. I take up a cup like this over here. Initially, I drill a small hole over here, a 1 millimeter radius, and then I make it as 1.5 millimeter. First cup. This is your first cup. Okay, I conduct 5 trials, and I get a mean of this one. Because when I am buying an apparatus, I should also look at it from the data collection point of view. Okay, it should not be something like I brought something and then the data did not come out. It is not so good. I should not do like this. I should always look at this also. So therefore, so I made a small hole over here. So 1 millimeter. Then I'm doing it to 1.5 millimeter or 1.2 millimeter, 1.4 millimeter, 1.6 millimeter. So I'm going to increase the diameter slowly, the radius slowly, and as a result of it, every 0.2 millimeter, as I keep on increasing it, definitely more amount of water will ooze into, the flow rate will increase. Now mark my term, I said something about flow rate. Okay, this is very important. Volume of water per second, how much does it enter? It depends on that. So the weight also increases correspondingly, and the bowl actually sinks faster. Okay, so therefore, so I can do this one. The other way of doing this one, see, okay, now the problem with this is that, so I didn't do this experiment. None of my students did this. Okay, so the problem with this kind of experiment is that when I increase the diameter, maybe for 1 millimeter, 1.2 millimeter, 1.4 millimeter, it will do properly. When I go to 1.6 and 1.8, who knows, the diameter is so large, it can immediately sink into. And you cannot find any difference between 1.6 and 1.8, or maybe 1.8 and 2 millimeters. Hardly the time taken would differ only by 1 second. Now, what do you do about it? Okay, so that's one problem, and you should be able to express this by means of a graph. See, when we are doing something, you need to look at that level also. Okay, so therefore, the sinking time in that case might initially it will be at this point at a smaller radius, but then it will slowly decrease like this, and after some time, it will come like this over here. So you should be able to explain this. Of course, this is a doable one. There are research questions based on this one. There is a research article also. You can look into it. So this is possible. Okay, this is perfectly possible. No issue at all. Okay, but only thing is, if you are so much focused on saying that for every reading, okay, the dependent variable should also change. So this you might not be able to get it across. Okay, the next one. Okay, the next one is that, let's say I take a bowl like this. I take a bowl like this, make a hole here, one hole. Then second hole, I make two holes. Then I make three holes. Now what happens is that when I make one hole, the bowl automatically sinks down vertically like this. When I make two holes, one hole here and one hole here, there's a possibility that more amount of water will ooze over here. So this becomes more weighter, and hence immediately there's a torque here, and this bowl tilts like this. When it tilts, what happens? All the water will immediately enter into it, and it immediately sink across, right? So when will this not happen? When I put one more symmetrically distance, equal distance hole at this point. When I do this, then through all the three holes, water will enter, and the water will now start rising like this over here. So as a result of it, okay, you can observe that it will not tilt. Okay, but still definitely will sink, but it will not tilt like that. Okay, so this is the problem. Now one more thing is that, see, when I take a circular bowl like this, I put one here, I put another here, then these three, the distance between them should definitely be larger. If there is a small mistake I made while I do a drilling, there's a possibility that these two holes will merge. Okay, this is the problem which we face. Okay, and I had to discard all the 7 cups which we brought in from Amazon, and I had to do something else. Okay, so as a result of it, this hole will become like this. Very, very huge one. We initially thought of doing only 1 millimeter. Now this 1 millimeter, adjacent 1 millimeter, this side 1 millimeter, 3 millimeters. In between, this is a small spacing of 0.5 millimeter. So 0.1, okay, so there is this 2 millimeter diameter, 0.5 spacing, 2.5, again 2 millimeter, 2.5 plus 2, 4.5, and then again 0.5, 5, and then 2, 7. So you get a big hole of around 7 millimeter. So therefore, the bowl now looks like this. Bowl now looks like this. So therefore, there's no point in doing such kinds of things. But if you really want to do this, okay, we changed this. What we did was, we did not choose a bowl like this. That's what I was saying about the shape of the bowl. The shape of the bowl should be like this. Should be like this. Okay, never take up a bowl like this. If you are taking up a bowl like this, then what you do is, don't increase the number of holes. Okay, only increase the size of the hole. That you can always do it. Okay, so therefore, now what is that we have seen? We have seen all the 3 ideas. Okay, weight of the bowl you can increase with only one hole. Okay, but the problem is you have to choose appropriate cups. Okay, or see to it that something has to be added. Maybe you can put something on the surface. The weight is equally being distributed on all the sides. You can do this one. Then diameter of the hole, you can raise the diameter by drilling larger and larger holes. You can do this one here. But if you get appropriate drill bits, because drill bits will be of the different sizes, so that is also a headache. The next one is position of the hole. So then based on this, we actually took up this one. Okay, now let me move on. So of these 6 ideas, I have now finally focused on this one, and I'm going to discuss only this part over here. Right. Now formulating a hypothesis. Now the problem is that, okay, now what is that we had? If the number of holes increases, then I put time of fall. What was our idea? The speed. Now, can you ever determine the speed? You can determine the speed only when you have a camera taking the part with it, and then you have to do tracker analysis, find out the video analysis, and then finally get the answer. Okay, but at the time, so I thought maybe instead of using something like speed, we can go with the time of fall. Okay, so this could be a better approach. Okay, as I felt. Okay, it's not that for everyone. Of course, if you have today, if you have a good camera and you're able to get that GoPro, for example, if you're using it, trying to get it, definitely, okay, you can calculate the speed. You can go ahead with the speed over here. Okay, so therefore, so I say that if the number of holes increases, then the time of fall will also time of fall will not increase, will decrease, will decrease. Okay, now give the reason. What is why do you expect so on? Why the reason is because more the number of holes, more the water will ooze through it, and as a result of it, okay, the time fallen will be lesser. But the only thing that you need to look at is that when you have a bowl like this is the center, then you should drill holes on equally like this. You should take a flat surface and you should drill holes whose diameter or radius is only 0.3 centimeter or maybe 3 millimeter. You can say start with 3 millimeter, 4 millimeter, 5 millimeter, 6 millimeter, 7 millimeter, and so on. And as you increase, definitely, so that you can choose only 3 millimeter. Sorry, you're not increasing the diameter. You are just choosing only 3 millimeter radius, or maybe 3 millimeter will be too high. I take 3 millimeter 3 millimeter diameter. Okay, and then initially I'll put only one hole. I'll take 7 bowls. I'll take one bowl here, put a 3 millimeter diameter hole here, and then I'll take another bowl with 2 holes over here, okay, which is again 3 millimeter. And the third bowl, I'll divide this into 1, 2, and 3. 3 holes over here, okay, and I keep on increasing like this. Okay, when I do something like this, then what will happen? I can ask this question, and then finally I can relate these two. Okay, now let me go on to the next one. So now we have decided about the independent and the dependent variables. What is your independent variable? Number of holes. What's a dependent variable? Sinking time. What's a control variable? You are not changing the density of the fluid, you are not changing the density of the bowl, diameter of the hole, everything is constant. Wow, we have finally arrived at a proper RQ, proper hypothesis, and looked also at the proper variables. Let me move further. Then look for the research articles. What does the research article say? Is there a math which has been connected with these variables? You need to look into it. Okay, there's already a math available. Okay, there are research articles. Just go through it. I'm not going to share anything over here. Okay, you can look into it. There are many articles available. The name of these articles starts with something called as Saxon bowls. Saxon bowls. What is this so special about it? This was one of the old concepts people had used to determine the time. Okay, how much time a bowl takes so that a Saxon bowl takes of a particular shape, okay, to immerse completely. That is what people had been found out. This is what got a Saxon bowls. There are several articles available. You can look into it. Okay, all this is being done. I'm not saying anything completely new over here. I'm just looking at going from knowns to knowns. Okay, a big project which people had done from 20 years back. I'm just taking up that one, and I'm saying, okay, why don't you carry out the same thing and infer from your side what is that you get? Okay, that's what we are doing. Okay, next, apparatus and setup. So I had already told you. So these kinds of bowls you can use, but the problem is plastic will have a density lesser than that of water, so it will definitely float. Okay, but when you put in water, weight of water will start entering into it, and thereby the weight will increase. So this might sink. So this is a possibility, but you can do only something like one hole. Okay, you cannot put multiple holes over here. So therefore, this you think about it. What is that you want to do? Then this is your flat metal cases. You can use this one. This would be a better one. Okay, so 470 rupees it costs, but anyway, you can do it. And you also need a drilling machine. Okay, so these are some of the equipments that you need. Okay, so that you can easily do this one. Okay, next, data collection. What is the data collection you do? Data collection is nothing but when I increase the number of holes, then what is the time taken? Sinking time. So that's what we have been looking. Say, for example, if I have 20 holes, of course, you will not get 20 holes. You will be able to get only some 5 holes, 3 holes, 4 holes, and so on. So as a result of it, when you do this, you get a graph like this. Okay, I've just taken some graph for the same from a given research article. Okay, for the same Saxon bowls. and this is what I have got. And then comes the evaluation. Okay, these two are very similar to what we have discussed in the previous videos. The first one is about the source of uncertainty and error. What is the source of uncertainty here? So you had a bowl, and then you drilled a hole over here, drilled a hole here. When you drilled a hole here, now how does the hole? If you zoom into the hole, what is that you can see? The hole might be like this over here. Though it is circular, it might be like this over here. The diameter may not be uniform. There could be a roughness over here. Okay, and as a result of it, water can move in different ways over here. Okay, so as a result of it, the amount of water that you get, okay, there could be a disturbances over it. The rate at which it goes might be different. Okay, so you can mention all this. Limitations of your method. Okay, mention about limitations. What is the limitation of this one? So for example, you took a bowl, immerse it in water. Okay, while you put your hand into it, and then okay, so there could be some disturbances being seen there. Okay, and as a result of it, water would have oozed into. Suggestions for improvements. Now, what is that you can improve over here? So you have to let us know. Okay, so think about, okay, what is the size of the bowl? Might be the size of the bowl may not be, okay, uniform. The thickness could have varied, or maybe, okay, you can do the same experiment with the help of a video tracker, okay, or some other sensors. You can mention all this. Strength of your conclusion. Okay, so what is the strength of your conclusion? You can mention about the RQ. Okay, so you said initially that as the diameter of the hole increases, or maybe as the number of holes in the bowl increases, you observe that the sinking time will also reduce, right? So this goes hand in hand with it. You can see that this is what is happening. You can mention all this over here. Then conclusion, finally. So clear and direct answer to the RQ, it's a repeat of what we have seen so far. And the interpretation of the uncertainties are the data, the process data. So what is the process data we are getting? Okay, you would have got something like 7 observations and 5 trials. You have found out, okay, that almost the consistency has been observed, or if the consistency is not observed, if there is an outlier, mention all this over here. Then reference to associated uncertainties, whether, okay, it follows a particular math, and if it follows a particular math, okay, find out, okay, what is the difference between the mathematically arrived values and the theoretically arrived, the experimentally calculated values. Get that value. Link to the scientific theory. Okay, so this is very, very important. Let us say in this experiment, for example, you might not be able to arrive at the math correctly. Okay, sometimes you might make a mistake. But what you need to do is you need to mention that such and such person has already conducted this experiment, and this is what is the graph he has got, and we also got a very similar graph. Okay, very, very important. Link to scientific theory with the accepted model. You need to look at the equations. See, IB is, once again I'm telling you, IB is all about, okay, so doing it's not about doing an experiment over here, it's about doing a research over here. Okay, so here you are being taught, or you are learning about how to conduct a research, okay, given a problem. Okay, so something which is completely new, which you have not learned in your syllabus. Okay, what is that you are going to do? How are you going to set up your experimental setup? What are the uncertainties associated with it? Are you getting a result correctly or incorrectly? You have to look at all these things, and you have to justify it also. Okay, so your conclusion should be based on all this. Okay, do not write, okay, my data was hand in hand with this, okay, so it went very well. Okay, these kinds of terms, nobody will accept it. Source citation that is traceable. Do not put Wikipedia articles, okay, as much as possible. Try to get an original article. Go to Google and search, and do not use ChatGPT for getting a citation. Because many of the times I have observed that when you use a ChatGPT or any other AI tool, Perplexity or whatever it is, okay, get a citation. That citation may not match with the actual article. So you might be making a mistake. Okay, so it should be traceable one. Then statement about how the consistent data is with the scientific context. So if the scientific context mentions that, okay, that the sinking time decreases with the increases in the hole, okay, and after some time it arrives at plateau region, then in your case also that should be observed. Which means what? You should have done a trial corresponding to it. Which means what? You should have referred to the research article before you started your experiment. Very, very important. Mark my point. So before you start your experiment, okay, you should have referred to the research article. Most of the students, what they do is, once they get their RQ by brainstorming, they get your hypothesis, they try to purchase the materials, and then you start working with this, you get the data, and you feel your experiment is done. And your writing part, you offer it to ChatGPT. okay, which is completely incorrect. Because ChatGPT is something like it has everything information, okay, but it only gives you an appropriate result if you are a good prompt engineer. You are giving a proper prompt, you'll get it. Okay, and it's not so easy. Okay, do not try to manipulate the results, because we know the moment we look at your IAs, okay, and then we'll get to know whether it has been generated by ChatGPT or it has been generated by yourself. Because ChatGPT is something like, okay, it's a machine-based model, it's a programmed experimenter. So what does it do? It always sees to it, okay, it's always correct, exact. Okay, but while we do as an experimenter, we may not get things correctly. We might make some mistakes, which only a teacher will understand. Okay, so with this, I think we have come to an end today's experimentation. And if you really like this video, do like, share, and subscribe to my channel. Let me know what else would you like to have in your future video sessions, and definitely I will be able to put across those. Okay, thank you very much for being with me.